Hi everyone, welcome back to Calculus 1 for students in international programs atเกษตรศาสตร์ University. Uh, some of you are probably get tired of me already, but I can't help, okay? So, we're gonna continue today with the derivative of trigonometric functions and the logarithm functions. So in the previous video, we learned the basic properties of derivative, right? The derivative of constant is 0. Derivative of x to the n is n x to the n minus 1, right? And then we looked at the chain rule, right? We looked at the chain rule. Oh, and there are two formulas that we have to remember. The first one is the derivative of uv is u dv plus v du, right? And the other one is the quotient, right? Derivative of u divided by v is low d high minus high d low divided by low squared, right? Divided by low, okay? And yeah, and that's it. So today we're gonna look at the derivatives of more complicated functions, for example trigonometry or logarithm, and the derivative of ux to the power of vx. Okay, so let's start with the derivatives of trigonometric functions. So as you know from the high school, right, that we have sine, cos, and tan, right? That's a basic thing. We have sine, we have cos, and we have tan. And if you remember, tan x is actually sine x divided by cos x, right? And we also have, what is it, sec x, which is 1 over cos x, and cosec x, which is 1 over sine x, and cot x, which is 1 over tan x, right? So we have these trigonometry, right? Trigonometric functions. So next, in this chapter, we're gonna be looking at the derivative of these functions. So these 6 formulas are the basic formulas that you need to be able to remember. Okay, so let's look at each of them individually. So the first one, the derivative of sine is cos, okay? D sine is cos, okay? That's easy to remember. D sine is cos, d cos is minus sine, okay? Don't forget, guys, d sine is cos, d cos is minus sine. See, it's not that d cos is sine. No, it's d sine is cos, but d cos is minus sine. D sine is cos, d cos is minus sine. And d tan is sec squared. D tan is sec squared. D sec is sec tan. D cosec is minus cosec cot. And d cot is minus cosec squared. Okay, so I'm not gonna give you the rhyme, in order to remember them. They are just 6 simple formulas. So I would like you to memorize them. Okay, d sine is cos, d cos is minus sine, d tan is sec squared, d sec is sec tan, and d cosec is minus cosec cot, and d cot is minus cosec squared. Okay, so if you want to prove, I'm not gonna be proving these formulas. But if you are interested, the proofs are in the book. Okay, you can go and have a look at the proof. They are not very hard, they are straightforward, but you would need to know the basic properties of trigonometric functions. Okay, otherwise it will be tough for for those who already forget or who don't even know the properties of the trigonometric functions at the first place. Okay, so but I'll just begin the proof for you. So if you want to prove that d psi by dx is cos x, so first you take the limit h approaches 0. That's the definition, right? And then you get psi of x plus h minus psi of x divided by h when h approaches 0. Don't forget, guys, this is actually the same as fx equals psi x. And then you use the property of psi x, right? You have that what psi of x a plus b is psi a cos b minus plus cos a psi b, and then you try to go from there. Okay, you try to go from there. It won't be that hard. Okay, cool. So guys, again, let's look at the formulas again. D psi is cos, d cos is minus sine, d tan is sec squared, d sec is sec tan, d cosec is minus cosec cot, and d cot is minus cosec squared. Okay, so let's look at these examples. So the first example is y equals x squared sec x. So we need to use the basic formula from the previous video as well. So here we have that this is u and this is v. So we need to use u dv plus v du. So we have that dy by dx would be, what is it? dy by dx is u dv. D sec is what? What is d sec? D sec is sec tan. So this is what we have. Sec tan plus v, which is sec x, du would be 2x. Isn't it? Isn't it? So the answer would be tan x plus 2x sec x, and that's the answer. Simple, isn't it? Simple, isn't it? The next question, y equals psi of square root x to the power of 4. Guys, psi x to the power of 4 is the same as psi x to the power of 4. They are the same thing. Okay, it's just notation. It's just notation. When we want to write the fourth power here, we can just write it here in front of n. Okay, sorry, above n. But it's not the same as psi of x to the power of 4. That's not the same thing. Because here it means that you take x to the power of 4 and then you find the psi of x to the power of 4. But here you find the psi x first and then you take psi x to the power of 4. So these and these are not the same thing. Okay. Okay. So here, if I, write it a bit more clearly, it will be x to the power of 1/2 and then of this to the power of 4. So in this case, we need to use the chain rule, right? So because why? Because we know how to differentiate x to the power of 4, which is 4 of x cubed, right? So outlet u be psi of x to the power of 1/2. So y would be u to the power of 4. And again guys, dy by dx is dy by du by dx. Okay, dy by du by dx. But dy by du is, what is it? Dy by du is 4u cubed, right? 4u cubed. And du by dx, what is it? Du by dx would be, so you need to differentiate. You need to differentiate psi of x to the power of 1/2. Okay. That will be du by dx. Okay, let me write it this way to make it more understandable. Okay, guys, again, here we know how to differentiate psi x. We know that it's cos x, but we don't really know how to differentiate psi of x to the power of 1/2, right? So we need to introduce another variable, which is w, and we let w be, of course, x to the power of 1/2. So we have that u is actually psi of w. So du by dx is du by dw and dw by dx. So du by dw, what is it? It will be just cos x, isn't it? Okay, can I just write it like that? Du by dw is just cos x, right? Because u is psi, sorry, it's not cos x, it's cos w. Why? Because u is psi w. So du by dw is cos w. D psi is cos. See? And dw by dx would be 1/2 of w to the power of minus 1/2. Okay. And then I'll have that is cos w divided by 2 square root of w. Okay. But w is what is w? W is x to the power of 1/2, right? To the power of 1/2. So here it's cos w divided by 2 square root of x to the power of 1/2. Okay. But guys, du by dw is just cos w, right? As you know, d psi is cos. Okay. And dw by dx is half of x to the power of minus 1/2, which is 1/2 square root of x. Make sense? Make sense? So we have that. Just use the black one. So we have that this guy is cos w, which is cos of x, cos of square root x, right? Because w is actually x to the power of 1/2, which is square root x, right? Du by dw is cos w, right? But w is square root x, so du by dw is cos of square root of x. And dw by dx is 1 divided by 2 square root of x. Okay, so again, we have here, what is it? dy by du is 4, dy by du is 4u cubed, right? dy by du is 4u cubed. So u, what is u? U is sine of square root of x cubed. Okay, and du by dx is cos of square root of x divided by 2 square root of x. Okay, and then I'll just cancel that, and that will be the answer. Make sense? First we look at this function. We let this be u. Why? Because we know how to differentiate this part to the power of 4. Okay, so in that case we let u be this guy, and then y is just u to the power of 4. dy by dx is this from the chain rule, and dy by du is this guy. Du by dx is this guy. Okay, but du by dx, we can't differentiate this function again, but we can differentiate it if we let this be w, is sine w. Okay, we know that sine w, the d of sine is cos, right? D of sine w is cos w. So we let w be x to the power 1 half, and of course u is sine w, and then we get, du by dx is this. So we computed the du by dw, which is this guy, and dw by dx, which is this guy, and then we substitute there. Okay, we put it there. Then when we have the du by dx, we put du by dx in there and dy by du in there, so we get the answer, which is dy by dx. Okay, we put, sorry, I probably spoke it incorrectly. We put du by dx in there and dy by du in there, so we get the answer, which is dy by dx. Okay, so that's why I told you that you need to understand the chain rule very well. Otherwise it will be quite difficult for you guys to do this computation. Okay, the next question here, it's sine of what? Let me rewrite it. Is sine of cosec x to the power of 7. And as you already familiar with it, here I'll let this be u, right? Because we know how to differentiate u to the power of 7. Okay, so I'll let u be sine of cosec x. So y is actually u to the power of 7. Here we have that dy by dx is dy by du and du by dx. Okay, dy by du is pretty simple. Dy by du is 7u to the power of 6, right? But du by dx is not straightforward. I'll just leave it there for now. Okay, du by dx, what is du by dx? Du by dx is to find d of sine of cosec of x by dx. And again, guys, you know how to differentiate sine, right? You know how to differentiate sine, right? But we don't know how to differentiate sine of cosec. So I'll let this guy be W. So the U is actually sine of W. So guys, again, du by dx, which is what we want here, is du by dw and dw by dx. And du by dw is what? Is the derivative of u, right? Which is du by dw, which is cos w, right? D sine is cos. And then dw by dx is the derivative of cosec, right? Derivative of cosec. What is the derivative of cosec? Is minus what? Remember? Derivative of cosec is minus cosec cot, right? So we have here, it will be minus of cosec x cot x. So cot is actually cosec is actually 1 divided by sine, right? Cosec is actually 1 over sine. So what I have here is minus cos w. Okay, I'll just leave it like that. So it will be minus of what? Minus of cos w, and w is cosec of x. I'll write it a bit better. Cos of w, but w is cosec of x, and cosec of x and cot of x. Okay, and that is du by dx. Cool. So can I just write it here? So we have that dy by dx is what? Dy by dx is, I'll continue from here, okay, is 7 u to the power of 6. But what is u? U is sine of cosec of x, okay, to the power of 6 times minus cos of cosec of x, cosec of x, cot x. Okay, and that is the solution. Okay, you can make it look prettier, but I think it's fine. Okay, just leave it like that. Make sense? Okay, let's look at another example. I'll just push it up a bit so that I have, more space to work with, the guy. So again, guys, as you can see, we kind of, we can't differentiate tan of cos, right? Tan of cos, we don't know how to differentiate that. But if we let this be u, so basically we let u be cos squared x. So y is just tan of u, and we know how to differentiate tan, right? That's tan of u or tan of x, right? So we know that dy by dx is dy by du by dx. And what is dy by du? Dy by du, what is the derivative of tan? Is sec of u squared, right? Sec of u squared, and du by dx. But du by dx again is not straightforward, because du by dx is cos x d cos x d by dx of cos x. Don't forget, u is cos x squared, right? So it's cos x squared. So we don't know how to differentiate this guy. We know how to differentiate x squared, right? Which is 2x. So again, guys, we let w be cos x. So u is w squared. So du by dx is du by dw and dw by dx. So du by dw would be 2w, isn't it? Right? Because u is w squared. So du by dw is 2w. And dw by dx would be derivative of cos. D cos is minus sine. So we have minus sine x here. So we have du by dx is minus 2. W is cos x and sine x. Okay. So we have that dy. Just write it here. Dy by dx is it's sec. I'll continue from here, okay? Is sec squared of u, and what is u? U is cos squared x. It's sec of cos squared x. Du by dx is minus 2 cos x sine x. Okay. So we can write it is as the minus 2 sine x cos x sec squared cos squared x, like that. But guys, if you remember the trigonometric formula here, 2 sine x cos x is actually the formula of sine 2x. If you do remember. So here we have that is minus of sine 2x sec squared cos squared x, and that is the answer. Okay. Some of you may ask me what happened if I don't know this, and I just answer it here. Because I'm kind. Okay, because I'm kind. So I'll still give you the full mark. I don't really mind. Okay, because teaching calculus, even if you're supposed to know, but I think it's fine. Right. Okay. The next question: y equals cos of sec of square root of x. No, the cubic root of x. It seems to be quite long. So how about I put another page here, and then I just remove this to the next page. Okay, so I'll remove this here. I'll move it here. Okay, and move it to the next page. So I'll delete, this guy. Okay, because in the Thai version, I did it in the shortcut way, in the quick way. But I realized that for you guys, you only study calculus 1, right? You don't do calculus 2 and 3. So it's probably better for you guys to follow the definition. Okay, but if you need to do calculus 2 and 3 and the ODEs and PDEs and more advanced calculus, I would teach you the shortcut ways as well, because it will be faster when you do calculus 2 and 3. Okay, but for you just to know the basic of calculus, I think it will be just better to follow the definition. Okay, guys, again, we don't know how to differentiate this function, but if I let this be u, okay, I let u be sec of x, like that. So I know that y is cos of u. Okay, cos u. So dy by dx would be dy by du times du by dx, but dy by du, d of cos is what? D cos is minus sine, right? D sine is cos, d cos is minus sine. So we have minus sine u and du by dx. Okay, but again, see, it follows the pattern, right? So du by dx, again, as I usually say, it's not straightforward because it's d of, what is it, sec of x to the power of 1/3 dx, and we don't know how to differentiate that function. But if I let this guy be w, so if I let w be x to the power of 1/3, we have that u is actually sec of w, right? So we have that du by dx is du by dw and dw by dx, right? And du by dw, what is it? D sec is sec w tan w. D sec is sec tan. Okay? Sec w tan w. And then we have dw by dx, which is 1/3 here, x to the power of minus the 2/3. Okay? So we have that du by dx is sec of w is x to the power of 1/3, right? Which is actually the cubic root of x, right? So I'll write it just like that, and tan of cubic root of x and 1/3 of x squared and the cubic root. Okay, and that's du by dx. So I'll just plug in du by dx in here. Okay, so I have that dy by dx is minus sine u. U is actually sec of right? U is actually this guy, which is sec of x to the power 1/3, which is the cubic root of x. Okay, and then multiply by du, which is sec of cubic root of x. Okay, let's write it a bit more clearly. Tan cubic root of x and 1/3 square root of x, cubic root of x squared. And yeah, to write it a bit more clearer, it would be minus 1/3. 3 is from here, I push it to the front. Okay, and the rest would be sine of sec of this guy times sine of this guy times tan of this guy times 1 over x squared cubic root, and it looks just like that. Okay, oops, sorry, this is sec, it's not sine, this is sec. Okay, and that is the answer. Okay, well, the next question, and it's the last question on derivatives of trigonometric functions. So here we probably need to use the quotient, the derivative of quotients, right? So dy is, what is it? Low d high, which is derivative of sine, right? Derivative of sine is what? It's cos low d high minus high, which is sine x, d low, the derivative of 1 is 0. Derivative of cos is d cos is minus sine divided by low. Okay, and here we have one, sorry, I just distribute cos x into the parentheses. So I have cos x plus cos squared x plus sine squared x divided by 1 plus cos x squared. But guys, if you remember the identity of trigonometric functions, we have that sine squared x plus cos squared x is 1. It's not just x, okay? Sine squared of box of anything, sine squared of 2x, sine squared of x cubed, sine squared of anything, plus cos squared of that thing is always 1. Okay, so here is sine squared plus cos squared, so that guy is just 1. Okay, it becomes 1. So we have that the answer is cos x divided by 1 plus cos x squared. Okay, makes sense? Oops, sorry, no, yeah, plus 1 here, my bad. Okay, because cos sine x squared plus cos x squared is 1, right? So it's 1 here. So is 1 plus cos x divided by 1 plus cos x squared. So we have that is 1 divided by 1 plus cos x. And that's it. Easy, isn't it? Okay. So next we're gonna look at the derivatives of logarithm and exponential functions. Okay, guys, first let's look at the basic formulas for the the exponential and logarithm functions. Okay, First we have that derivative of log x is 1 over x. Okay guys, when I say log x, I mean log x based e, okay? When e is a natural number. Okay, so it's when I say log x in this level, in the university level, we usually use the logarithm base e. Okay, so the logarithm is based e. When e is a 2.7, 1/8, 2/8, 1/8, blah 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 blah. Okay, so so here, when I say log x, I mean log of x base e. And guys, don't forget, log e is 1. Why? Because log e is log e base e. And we have from high school that log of a base a is 1 for any a, right? Right? Okay. So the second one is that log of x base a, when a is any numbers, is 1 over x log a. Okay, it's 1 over x log a. Actually, this one is pretty easy to prove. Why? Because from high school, you know that log of x base a is log of x divided by log of a. Right? Right? From high school, you have a property of log, which is that log of a base b can be written as log of a base c. Just remove my log of a base c divided by log of b base c. So basically, we can change the base. Okay. Okay. Cool. So in that case, if you find a derivative of this guy, log a is a constant, right? A is a number and log a is a constant. So I pull 1 over log a out, and the derivative of log x is 1 over x. That's why here is 1 over x log a. Okay. The third formula is that derivative of e to the x is e to the x. Okay, it doesn't change. So if you have e to the x, you differentiate it. It's still e to the x. It doesn't change. Okay. Derivative of a to the x when a is any number is a to the x log a. Okay. Okay. So let's look at some easy example here. I'll just write some easy example here. D by dx of log x, of course, that from the formula is 1 over x. D by dx of log of x base 10, that is actually 1 over x log 10. Okay, that's the second formula. Okay. The third one, d by dx of e to the x, that e to the x is the same as the third formula. And the fourth one, d by dx of 2 to the x, that is 2 to the x log 2. Okay, and that's the fourth formula. Okay, so guys, you need to be able to memorize these 4 formulas. D of log x is 1 over x. D of log x base a is 1 over x log a. D of e to the x, e to the x. D of a to the x, is a to the x log a. Okay? Okay. Cool. Okay, guys. Before we proceed to the, examples of the derivatives of logarithm and exponential functions, I changed my mind. So I'll teach you the shortcut of doing chain rule first. Okay, otherwise it will be really troublesome for you guys to work with really complicated functions. Okay, so let's look at this one, chain rule revisited. Okay, we get back to the chain rule again, but for this one I'm not going to use u and w anymore. Okay, I'm not going to use u and w anymore. Okay, so what I'm going to do is that here we can't differentiate this guy, right? So before this we need to let this be u, right? And then blah 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 blah. Okay, I'm not going to do that. I'm just gonna look at this as x, the big x, the big x. So the derivative of big X is what? 3 big X squared. 3 big X squared. And then you need to differentiate the big X by X. Okay, okay. Again, I'll look at this guy as a big X. And I can differentiate big X cubed, right? So the derivative of big X cubed is 3 big X squared. And then by the chain rule, we differentiate the big X by X. Okay, so what we have here is 3 big X cubed and then d by dx of the big X. See? And for this function, we can differentiate it, right? We can differentiate it. It's 2x plus 1. So we don't need big X anymore. Okay? So what we have here is 3 2x plus 1 squared times 2, which is 6 2x plus 1 squared. That's it. Okay? So we don't need to introduce the variable u anymore. Okay, I assume it's a lot easier. Okay, so the next one is simile here. First I'll just write this as d by dx of x cubed plus 2x squared minus x plus 1 to the power of 1/2. Okay, and I take derivative of that. Okay, I differentiate that, but in the previous section we need to define this as u, right? But I won't do that anymore. Again, I'll look at this as a big X. So derivative of big X to the power of 1/2 is 1/2 big X to the power of what? Is 1/2 big X to the power of minus 1/2, right? Right? So what I have is 1/2 big X to the power of minus 1/2. Okay, and then times d of big X, which is this guy, by dx. Okay, and that is 1/2 of 1 over square root of x cubed plus 2x squared minus x plus 1. Okay, and the derivative, this derivative is, you don't need the chain rule anymore, right? You can differentiate this guy. So is 3x squared plus 4x minus 1, and that is the answer. So it's easy, isn't it? Okay. Okay. The next one. Again, I'll look at this as x. So I just differentiate sine x, which is cos x, the big X by the x. So I'll look at this as big X. So derivative of sine big X is cos big X and then the big X by the x. Okay, okay. In that case, this becomes cos of 2x squared and times 4x, and that's it. See, we don't need u and w anymore. Clear? And similarly here, I'll look at this guy as a big X, So what I have is that it will be tan. D tan is sec squared, right? So we have sec of big X squared, and then d of big X by the x. See, this is the big X. This is the big X. D of tan big X is sec squared, right? Oh, sorry, I forgot the square part. Okay, here is not squared. Here is like that. So, d of tan is sec squared, right? D tan big X is sec squared big X, and then you differentiate big X by x. Okay, again. Differentiate tan of big X is sec squared x and the x by the x, the big X by the x. See? And here is sec squared of cos of minus x cubed, right? Here it's done. This guy is done. You don't need to do anything with it. Just copy and paste. Okay? So after that, we're gonna differentiate this function. But again, guys, we don't know how to differentiate this function. So we let this be the big X, another big X. So differentiate cos of big X is what? Is minus sine, right? So we have minus sine of big X. See? And d of big X by dx. Make sense? See? Differentiate cos of big X is minus sine of big X and then the big X by dx. That's the chain rule. Okay. So what we have here, I'll just move it. Oops, sorry. Just move it a little bit to the left hand side so that I have, a little more space. And I'll make it a little smaller as well. So here, what we have is sine squared cos of minus x cubed. And guys, as I told you, this is done. Don't touch it. Okay, don't touch it. And again, this is done as well. So don't touch it. It will be minus sine of minus x cubed. And derivative of minus x cubed is minus 3x squared. And that's the answer. So we don't need u and w or any of those anymore. So we keep differentiating by introducing x. Okay, let me summarize this one for you. Here I look at this as a big X. So derivative of big X is derivative of tan x is sec squared. Okay, and then you take the derivative of big X by X. That's the chain rule. Okay. After that, we're gonna find this derivative, right? This is done. This is done. Gonna find this derivative. So we look at this as the big X. So derivative of cos is actually minus sign, right? Minus sign of big X and then derivative of big X dx, right? And this is done. This is done. Don't touch it. Just copy and paste. Okay. Okay. And then we need to work with this one. But this one is derivative of minus x cubed. So we don't need the chain rule anymore. Right? Right? So we can differentiate it easily. So it's minus 2x squared. So whenever we don't need the chain rule, we don't need to differentiate the big X because there's no big X to differentiate. Okay? Okay. That's the fast way of doing chain rule. And you can use that in the exam as well. I don't mind. Okay. So let's go back to our topic, the derivatives of logarithm and exponential. Okay. For some of you who already forgot the formula, d of log is 1 over x. d of log x with base a is this. d of e to the x, e to the x. d of a to the x is a to the x log a. Okay. Okay, guys, let's look at this one. Here we have u and v, right? Right? Is a multiplication of two functions, right? Exponential and trigonometry. Okay. So dy by dx would be, what is it? U, right? Sorry, u, which is e to the 3x. dv, what is dv? Is derivative of sine 2x, right? So you look at this as the big X. So derivative of sine x is cos x. See? Derivative of sine x is cos x. And then you need to take d of big X by dx, right? For chain rule. So d of 2x is actually 2. And that's it. U dv. And then you plus v which is sine 2x. du is e to the x, right? Oops, sorry. E to the x, right? Derivative of e to the x is e to the x, and then you d this by the x. Make sense? So we have e to the x, and then d of 3x by dx is 3. Okay? u dv plus v du. Okay? So we have that. The solution is e to the 3x. I pull that out. So I have 2 cos 2x plus 3 sine 2x. Okay? And that's it. Easy. So for this one, if you want to use, chain rule by introducing u and w, oh, it's gonna be a nightmare. Okay. Okay, let's look at another example. Here again, we have u and v. Okay. So dy by dx is u, which is e to the minus 3x. dv, what is dv? dv is log of x. Log of x, derivative of log of x is 1 over x. The formula, if you don't remember, go back and look at the formula. Okay, derivative of log x is 1 over x, and then you need to differentiate the big X by the x, right? Right. So is, what is it? 1 over x squared plus 9, and that will be 2x. Plus v, which is this guy. du again, we look at this as the big X. So derivative of e to the big X is actually e to the big X, and then you take this guy by the X. Okay. So what we have is e to the minus 3x, and then derivative of minus 3x by the x is minus 3. So here, what we have is 2x e to the minus 3x divided by x squared plus 9 minus 3e to the minus 3x times log of x squared plus 9. And that's the answer. Okay. Is it too hard? I hope it's not too hard, okay? Once you can master the chain rule, it's going to be really easy. Okay, nothing hard. The others are just, formulas. If you can memorize the formulas, things are fine. Things are easy. Okay? Okay, the next example. Here, we have, what is it? It's the quotient again, right? It's the quotient again. So, dy by dx would be low, which is e plus e to the x. Low d high would be just 1 over x, right? Low d high minus high, which is log x. D low would be e to the x. Why? Because d of e is 0. Don't forget, guys, e is a number. It's 2.7 something. It's just a number. So derivative of e is 0. But derivative of e to the x is e to the x. Okay? Divided by low. Okay? So, the answer is e plus e to the x, 1 over x minus log x e to the x. Can I put e to the x first and log x? But guys, I want to make it prettier. I want to subtract these two terms. So can I do this? I multiply both sides, the up and down by x, and then this divided by e plus e to the x squared. So what I have is e plus e to the x minus e to the x log x times x divided by x e plus e to the x to the power 2. This x here here. Okay, and this x here. Make sense? And that is the answer. How about the next one? The next one again is u and v. Right? So dy by dx is u, which is x. dv, what is dv? I'll look at this as the big X. So derivative of e to the x is e to the x, and then the big X by dx. Okay. So what I have here is e to the x, and okay, I'll do it slowly. Okay, derivative of e to the x is e to the x d the big X by dx. Okay, plus v, which is e to the sec x, du would be dx by dx, which is 1, right? Dx by dx is 1. So we have here x e to the sec x, d sec x. What is d sec x? D sec x is sec tan. So we have sec x tan x plus e to the x, sorry, e to the sec x. So if I pull e to the sec x out, I have sec x tan x plus 1. Oops, sorry. Just like that. Simple, isn't it? Okay. I hope it's not too hard. Okay. Well, next question. If you look at this guy, it's gonna be really troublesome if you want to use the chain rule. I don't know, 4 times. You're gonna need u, w, and probably s and t. I don't know. You're gonna need lots of variables. So how about this? How about this? First guy, I look at this as x. So derivative of log x is 1 over log x d big X by dx. Right? Right? So here, what I have, dy by dx is 1 over this guy. Right? And this guy by dx. Right? Again, guys, look at this as x. And then d of log x is 1 over x. See? D big X by dx. And guys, as I told you, this is done. Don't touch it. Just copy and paste. Okay? So, is 1 divided by log of cos x. Okay? Okay? And then if you look at this derivative, again, you just look at this as another big X. Right? It's a log of x again, right? So it's 1 over x dx by dx. Make sense? Make sense? So here, I have that is 1 divided by log of cos x d log of cos x by dx. And then guys, again, these two terms are done. Don't touch them. Just copy and paste. Okay. And next, we have that is 1 divided by log of cos x, 1 divided by log of cos x. And then guys, again, we look at this as a big X. See, we keep doing that. Log of big X. So it's gonna be 1 over big X d big X by dx. Okay, so what you have is 1 over cos x and d cos x by dx. Okay, and again guys, these are done. Don't touch them. Okay, don't touch them. Okay, guys, actually if you want, you can just do it within 1 line, but I won't recommend. Okay, you can get things wrong pretty easily. Okay, so here is 1 divided by log of cos x, log of cos x, 1 over cos x, but derivative of cos x here, guys, it's cos x, isn't it? We don't need the big X anymore because it's just the derivative of cos x. It's not cos x squared. It's not, you know, cos something x. It's just cos x, so we know the formula. The derivative of cos x is just minus sign. Okay. So guys, here sine divided by cos, that is tan x, isn't it? It's tan x. So the answer is minus tan x divided by log of cos x, log of cos x, and that's it. That's the answer. Okay, this is tan from sine divided by cos. Okay, how was it? It's like 1, 2, 3, 4. It's like, you know, to apply 4 chain rules. Okay. The next one. Dy by dx. Guys, again, we look at this as a big X. Okay. So, derivative of cot is minus cosec squared, right? So here is, what is it? Minus cosec squared of this guy. And we take the derivative of the big X, which is this guy. Okay, I think it's quite hard to read. Let me make it a little more, a little easier to read. So it's minus cosec of log of tan x squared, and then d by dx of log of tan of x. Okay, so here guys is cot of x, cot of big X. So from the formula, d cot is minus cosec squared. So we have minus cosec squared. Okay, and then we differentiate the big X by the X. Okay, and again guys, this is done. Don't touch it, just copy and paste. Minus cosec squared of log of tan x. And guys, again here we look at this as a big X. So it's log of tan x, right? Log of big X. It will be 1 over big X, the big X by dx. Okay, so what we have is 1 over tan x and d tan x by dx. So we have minus cosec squared log of tan x divided by tan x, and then derivative of tan is sec squared. Okay, and that's the answer. Easy, isn't it? Okay. Okay. And guys, that is done for the, let me sum it up. In this video, we did 2 things. The derivative of trigonometric functions, right? Sine, cos, tan, cosec, sec, cot, right? So you need to remember, you need to be able to memorize the 6 basic formulas. And after that, we look at the derivatives of logarithm and exponential functions, right? We have another 4 formulas, right? And I also told you how to do the chain rule in the faster way. Okay, so guys, just again, I know I told you in the previous video as well, but you need to do exercises. Okay, you need to do exercises. I think this video is quite long, so I'm not going to do the derivative of ux to the power of vx, but I'll do it in the next video. Okay, so in the next video we're gonna look at the derivative of ux, which is a function of x, to the power of function of x. Don't forget guys, in this video, we only look at the exponential functions, which is number to the power of x, right? To the power of function of x, but the base is just a number. But in the next video, the base can be a function as well. Okay, so it will get a little more tricky. But guys, if you master chain rules, if you master the basic formulas for logarithm, exponential, and trigonometric functions, you're gonna be fine. Okay, so see you in the next video. Bye bye.